This is section 5.4, sum and difference formulas. This is the objective. You can pause to read it, but I'm going to move on to the next slide. Vocabulary key concepts: compute trigonometric functions at special angles, verify identities. By the end of this video, you should have an idea how to compute sine of 15 degrees without using the calculator. Notice that this is not one of those special angles that you see in the unit circle. Moving on to the next slide. These are formulas that you need to have memorized. Start with the first one. This is the sum of sine of two angles, in this case u and v. And that is equal to sine of u cosine of v plus cosine u sine of v. 2. Sine of u minus v is equal to sine of u cosine of v minus cosine u sine v. Now let's go to cosine. Cosine u plus v is equal to cosine of u cosine of v minus sine u sine v. 4. Cosine of u minus v is equal to cosine u cosine v plus sine u sine v. To help you just memorize this a little bit, these two formulas, listen to what I'm going to say. Notice that sine, if here you have plus, here you have plus, minus, minus. And sine, somewhat, you should notice this pattern: sine and cosine, cosine and sine. Is a combination of sine and cosine whenever you deal with sine. Notice the same thing here: sine and cosine, cosine, sine. Both. Now, when you go to cosine, it's slightly different. Here, you only have one trig ratio: cosine, cosine, sine, sine, cosine, cosine, sine, sine. Unlike these, you have both trig ratios. And notice another pattern. If you have a plus here, over here you have a minus. If you have a minus, over here you have a plus. So hopefully this will help you memorize this. And then you have two more for tangent. This is the first one. U plus v is tangent of u plus tangent of v, and then 1 minus the product of tangent u tangent v, which is what you have here. And the other one is tangent of u minus v is equal to this. Notice the sign: minus, minus, plus, plus. And the denominator is the opposite sign. Okay, so moving on. This is the first problem. It says find the exact values of sine, cosine, and tangent of the angle. If you look at this radian measure, you're not going to be able to find it on the unit circle. To help you see it a little bit better, this is equivalent to 255 in degrees. And you know how to change radians to degrees. So the way that I'm going to be able to get 255 is I'm going to be doing the following computation. I'm going to be adding two angles: 210, which is, notice this is an angle in the unit circle, and 45, which is an angle. These are two special angles that you see in the unit circle. So now to compute sine, this is what I'm going to do. Sine of 255 is sine of 210 plus 45. And notice that I'm going to be using one of those formulas that you saw on the previous slide, which is formula 1. So then you have, if I apply the formula, sine 210 cosine 45 plus cosine 210 sine 45. And then you refer to the unit circle, and you should be able to see why we have sine of 210 is negative 1/2 45 radical 2 over 2 plus. And then cosine of 210 is negative radical 3 over 2, and sine of 45 is radical 2 over 2. And then at this point, you're basically going to apply your pre-algebra skills, and you get the following. And this is your answer. Sine of 255 is equivalent to this. Now let's compute cosine. So I'm going to basically use the same sum, 210 plus 45. So cosine of 255 is equal to this. I apply which formula? This is if I number them, so this is the number 3. So that's how you get cosine 210, cosine 45. And like I mentioned earlier, this is plus, now it's minus. And notice that you have the same trig ratio, cosine, unlike sine, which you have both. And then minus sine 2tan, sine of 45. You refer to your unit circle. This becomes negative radical 3 over 2, cosine of 45, radical 2 over 2, minus, and then sine of 2tan is negative 1/2, sine of 45, radical 2 over 2. Pre-algebra, you get the following. And this is your answer for cosine of 255. Going on to tangent. Tangent of 255, now I'm going to use that formula, and I'm going to be using the fifth formula. So then I have tangent of 2tan plus tangent of 45. When this is plus, the numerator is plus, and the denominator is minus. 1 minus tangent of 2tan, tangent of 45. Then I apply my unit circle. That's how I end up with radical 3 over 3 for tangent to 10 plus 1 for tangent of 45 and so forth. 1 minus this gives me radical 3 over 3 times 1. At this point I'm going to add these two fractions, so I'm going to give them the same denominators, and then that's how I end up with 3 radical 3 plus 3. The denominator is the same thing. Two fractions, I'm going to give them the same denominator, and that's how I end up with this. You should be able to see that these go away if you multiply top and bottom by 3. And that's how I end up with 3 plus radical 3 plus 3 over 3 minus radical 3. At this point, you don't want to leave the answer like this because you have a radical denominator, which means that you have to rationalize. So you have to multiply this. You're going to have to multiply top and bottom by the conjugate of this denominator, which is 3 plus radical 3, 3 plus radical 3. Do some algebra here. You FOIL and you get this. In the denominator you FOIL and you get this. You simplify the numerator. Notice that this is just 3. That's how this becomes 12, and this is 6 radical 3. And then this is 9 minus 3, which is 6. Notice a common factor here. So you get rid of it. And that's how you get 2 plus radical 3. This is the answer for tangent of 255. Moving on to number 2. So we're looking at same problem. Now you have a different angle. You also have it in radians. You should be able to compute that and change it to degrees. Excuse me. So then from here, I'm going to compute sine of negative 285. So I need to come up with the sum of two special angles that give me negative 285. And I use 30 and 315. I subtract them and I get negative 285. So now I'm going to compute sine. Sine of negative 285 is equal to, I'm going to be using formula number 2. Once I apply it, this is what I get. Sine of 30, cosine of 315, minus, because this is minus, cosine of 30, sine of 315. And it's basically, like I said, you apply the formula. Apply this, apply the unit circle, and you should be able to see how we get the following fractions here. Pre-algebra, and that's how we get 6. Radical 6 plus radical 2 all over 4. Cosine of negative 285, I use the same difference. Apply the formula. In this case, I'm going to apply the fourth formula. Notice that this is minus, over here is plus. You notice you have the cosines together and then the sines together. Simplify this using the unit circle. That's how we get this. Apply some pre-algebra. And this is how we get radical 6 minus radical 2 divided by 4. Now we need to compute tangent. So notice that in this case I have tangent of negative 285, which is the same thing as, if I apply my quotient identities, sine of negative 285 and cosine of negative 285 is the same thing as tangent of negative 285. I know what this is, which is right here. I know what this is, which is right here. So this is another way that I can do this problem. I can go through the formula number, you would be using formula number 6 here, and you will still get the same answer. But since I already know what sine of negative 285 is and cosine of negative 285, which is here, like I mentioned, all I need to do is, this is in my numerator, this is in my denominator. I simplify this. Notice that the 4's go away. Multiply top and bottom by 4 of this fraction. And then at this point I have radicals in the denominator, so I need to rationalize this. So I multiply top and bottom by the conjugate of the denominator. This is just algebra. That's how I end up with this as the product. From here I simplify. Common factor of 4, and that's how I get 2 plus radical 3. In other words, I divide the 4 into this first term, divide the 4 into the second term, and that's how I end up with this. So we're done with number 2. This is the answer for tangent of negative 285. And like I mentioned, you can apply that formula, which is, which formula would this be? This will be the 6th formula, and you should get the same answer. Moving on to number 3. This one's just a little bit different. It says write the equation as the sine, cosine, or tangent of the angle. Basically, this is what you need to do. You need to recognize that this is related to formula number 4. Once you see that this is related to formula number 4, you should see where this is coming from. When this is a plus, this is a minus. So you just take these two angles. This is like your U. This is like your V, U, V. You apply the formula, and that's how we end up with this. And then you simplify this, 0.96 minus 0.42, and that's your answer. So we are done with number 3. You don't have to compute this on the calculator. Number 4, again, we need to apply one of the formulas you saw on an earlier slide, and this turns out to be formula number 6. So that's how we end up with tangent of 154 minus 49. Subtract these two angles, and that's how we end up with tangent of 105. Moving on to the next slide. This one's a little bit different. It says find the exact value of the trig function. They want you to compute cosine of u minus v. And they give you this trig ratio, sine of u, which is equal to 5 over 13, and cosine of v, which is negative 3 over 5. And they give you information about the u and the v. They're telling you that u is in the second quadrant, and so is v. So this is going to give you information, and the sign of the trig ratio plays a key role here, because u and v are in the second quadrant. And then I'll highlight the sign of the trig ratio in just a little bit, but you should be able to see that if I draw a right triangle and use my reference angle u, I end up with 5, 13, and the adjacent angle to reference angle u, you know, is 12, using the Pythagorean theorem. In the same manner, cosine of v, I use v as my reference angle, I draw a right triangle, and this is what I get. And you should be able to come up with this third side of the right triangle. And again, I'm ignoring the sign for a second. So now, this is what I need to compute cosine of v minus u. So then, if I apply the formula number 4, this is what I get. Now I need to write cosine of v. So this is my reference angle v. So cosine of v is 3/5, but notice that I'm in the second quadrant. So you should be able to see that this is going to be negative. Cosine of u, this is my reference angle u. U is in the second quadrant, so you know this is also going to be a negative ratio. And then sine in u, second quadrant, the sign is positive, so I'm not even going to worry about that. So now, this is what I get. Cosine of v is 3/5 negative. Cosine of u is 12/13 negative. And you know that this is just positive. So then all I'm going to do is a little bit of pre-algebra here. And that's how I end up with the following. I simplify, and this is my answer to number 5. All right, now there's a little f-squared for you. You see if you can answer it. But moving on to number 6. So now I'm looking at sine of v minus u. Very similar. And notice that u and v, the sine and the cosine of u, sine of u, cosine of v, are the same from problem number 5. And u and v are on the second quadrant. So I have basically the same right triangles here. And again, I have to take into account the sign of some certain trig ratios here. So I'm computing sine of v minus u. I apply a formula number 2, and this is what I get. Then I'm going to go and look at my reference angle v, and then I'm going to compute sine, reference angle u, compute cosine, and notice that this is going to have to be negative because I'm in the second quadrant. Sine, the second quadrant, still positive, and you should be able to follow the same thing here. So now this is what I get. 4/5 times, again, negative. This is just minus, bring it down. Sine u, positive 5/13. Refer to your right triangles here. Cosine of v, you know it's negative because we're in the second quadrant. Simplify, and this is what you get. This is your final answer for number 6. Another f-squared. Let's see if you can come up with a good explanation. Moving on to number 7. Same type of problem, but now I'm asking you to compute the tangent of v minus u. Notice that you have the same trig ratio, sine of u, 5/13, cosine of v, negative 3/5, and you're looking at u and v in the second quadrant. So we have the same right triangles as the previous 2 problems. So then I apply my formula number 6, and this is what I get. So now tangent of v, tangent of u, since my angles are on the second quadrant, you should know that all these trig ratios that you see here are going to be negative. So now I go to tangent of v, which is going to be 4/3, and you know it's going to be negative. Tangent of u, my reference angle u is over here, is 5/12, second quadrant, so you know it's going to be negative, and so forth. That's how I end up with negative 4/3. Bring the sign over, and then tangent of u is negative 5/12. The denominator is 1 plus the product of the 2 numerators here. I do a little bit of algebra here, and I'm skipping some steps, but you should feel comfortable with the algebra. The pre-algebra. And that's how I get negative 11/12 in the numerator, and the denominator I get 56/36. I multiply top and bottom of the reciprocal of the denominator, and that's how I end up with this, and this is my final answer, negative 33/56. Now, is there another way of doing this problem? Of course there is, and this is the other way of doing this problem. This is the OR, using 5 and 6. Notice that you're computing tangent of v minus u. Tangent of v minus u, if you use the quotient identities, is the same thing as sine of v minus u over cosine of v minus u. You found out that this is negative 33/65 on a previous problem. Cosine of v minus u is 56/65. Do a little bit of pre-algebra here, and that's how we end up with this answer, which is the same as using the other formula. And this is the end of the